primarily a system for building virtual environments that can be run in the browser. You could think of Wanix as a Docker that runs in the browser, though it is a very different approach since it can be used in a number of other ways as well. For example, previous releases explored using it to build a whole new general-purpose computing environment in the browser. We're building developer tooling that otherwise wouldn't run in the browser, allowing us to build a polyglot development environment without cloud servers. That means running everything sandboxed locally in your browser. To be clear, Wanix is plumbing. For now, it will likely only appeal to system builders, tool developers, and those of you interested in a future of malleable local-first software like us. This demo will show some of its capabilities, but at this point you'll still have to imagine specific use cases on your own. And if you are able to, please share potential use cases in the comments for those that might not. That said, let's get into it, starting with some background. The heart of Wanix now is a VFS module, or Virtual File System module. This VFS module is more than just an in-memory file system. It's much closer to the Linux VFS layer. The VFS in Linux is what gives us a single file system view, even though it's made up of several underlying file systems. One might be a partition on the hard drive, one might be held in memory like tempfs, or maybe it's removable media like a USB stick. The Linux VFS is like a router or switch delegating operations to the underlying file system mounted at a specific path. However, the underlying file system doesn't have to be a storage medium. It could be an API to some system or device. If you've heard of device files, these aren't normal files. They're files representing a way to read or write bytes to a real or virtual device. This goes all the way back to the origin of Unix. The authors of Unix at Bell Labs realized they could use the file system as a user-facing API to their terminal devices, also known as teletypes. This worked particularly well because the protocol to a terminal device was a read-write stream of bytes to display and bytes typed in. This led them to think of the file system more as an abstraction or an API. Encoded in the Unix philosophy, everything is a file. Then, in the late 1980s, the same team at Bell Labs that built Unix created a successor trying to bring deeper compositionality into the design of the system. This successor to Unix was called Plan 9. It took everything as a file to a new level, yielding a system with capabilities we still haven't seen in mainstream operating systems, while being an order of magnitude simpler. In Plan 9, there is no single file system view. Instead, every process has its own file system called a namespace. Child processes inherit namespaces, so by default it feels like a single file system, but you can customize the file system for any individual process. In today's terms, it's the equivalent of every process running in its own container. On top of this, namespaces in Plan 9 are constructed more granularly using file services. File services are assumed to not necessarily be storage volumes, but generic capabilities. There's a file service for getting the mouse position, a file service for drawing to the display, even a file service for working with network sockets.